A truck depot in Inner Mongolia. A driver pulls in, and in under 5 minutes he drives back out with a full tank. Except there is no tank, no pump, no diesel. A machine has just pulled the entire battery out from under his truck and slid in a fresh one. By December 2025, more than half of every new heavy truck sold in China in a single month ran on exactly this. Quietly, with no press conference and no headline event, the world's largest oil consumer let its own fuel demand tip into decline for the first time in 20 years. This is the story of how that happened on purpose, and the industry now scrambling to survive it. For most of the last 100 years, there was a rule that nobody had to write down because everybody already understood it. Whoever controls the fuel controls the leverage, not the country with the most factories, not the country with the biggest army on its own. The country that decides who gets to fill up and at what price. A handful of oil majors, once nicknamed the Seven Sisters, effectively set the global price of crude for most of the 20th century simply by controlling where it came out of the ground and who was allowed to refine it. In 1973, a group of oil-producing nations proved that leverage in a matter of weeks. They tightened the tap in response to a war on the other side of the world, and the industrialized economies that depended on that oil watched their stock markets crater and their gas stations turn into mile-long lines almost overnight. For half a century after that shock, energy security meant one thing above all else: guaranteed access to oil and the pipelines, tankers, and refineries that moved it. Governments built entire foreign policies, entire military postures, entire diplomatic alliances around that single vulnerability. Every major economy on Earth structured itself around a fuel it could not grow, could not manufacture domestically at any real scale, and could not fully control the price of, no matter how large or advanced that economy became. There's actually a much bigger story behind all of this that I couldn't fit into this video. So I put it together in an ebook for anyone who wants to go deeper. You can find it in the description or scan the QR code on screen. Now let's get back to the video. China understood that vulnerability better than almost anyone because China lived it directly. By the mid-2000s, the country was importing more crude oil every year just to keep its factories running and its highways moving. Between 2005 and 2024, Chinese oil consumption more than doubled, and China alone accounted for over half of the entire increase in global oil demand across those 2 decades. It became the largest crude importer on the planet, dependent on tankers crossing thousands of miles of open ocean, much of it through a single choke point in the Persian Gulf that China did not control and could not defend. That is an uncomfortable position for any government to sit in for very long. So while the rest of the world kept debating whether electric vehicles were a serious industry or a subsidized science project, China quietly treated it as a national vulnerability to be engineered out of existence. Here is the part almost nobody outside the energy industry has been tracking closely enough. Fuel demand is invisible until the moment it breaks. You do not think about the refinery that turned crude oil into the gasoline in your tank. You do not think about the pipeline network, the tanker schedule, the decades-old chemistry of a combustion engine sitting under the hood. You just pull up to a pump, and it works, the same way it worked yesterday and the way it will work tomorrow. That invisibility is not an accident. It is the entire point of a mature fuel supply chain. It is supposed to disappear into the background so completely that an entire population can go decades without ever having to think about it. You only hear about the oil industry when something breaks. A war disrupts a shipping lane, and suddenly prices spike at every pump in your city. A refinery catches fire on the other side of the planet, and your commute gets more expensive by the following week. Then the disruption passes, prices settle, and the entire machine goes back to being invisible again. Refiners, in the meantime, built enormous capital-intensive plants designed to run for decades at a stretch, confident that as long as internal combustion cars kept rolling off assembly lines, gasoline demand would keep climbing in something close to a straight line forever. That assumption held for 100 years, across wars, recessions, and oil shocks that came and went. Then, without a single dramatic headline to mark the moment, it stopped being true in the one country burning through fuel faster than anywhere else on Earth. The shift did not begin with trucks. It began somewhere almost nobody was watching. In the early 2010s, Chinese subsidies quietly nudged electric buses into city fleets. Buses were the easy target. They run predictable routes, they return to the same depot every night, and a depot is exactly where you want charging infrastructure concentrated, because you only have to build it once. Electric buses proved the concept worked at scale without anyone outside the transit industry paying attention. Then passenger cars followed, backed by more than a decade of subsidies designed to give domestic automakers time to bring battery costs down and scale up production before global competitors caught on. In the first 5 months of 2021, electric and plug-in vehicles made up roughly 9% of new car sales in China. By the same point in 2023, that number had jumped to 28%, while the share of pure petrol cars collapsed from 91% down to 72%. By 2025, electric and hybrid vehicles together accounted for close to half of every new car sold in the country. What took Europe and the United States more than a decade of stop-and-start progress happened in China inside a single presidential term's worth of years. Then the forecasts started breaking. Energy analysts do not like being wrong about long-term demand curves because entire refineries get built or canceled based on those numbers. In 2023, the state fuel distributor Sinopec projected that Chinese gasoline demand would peak that very year, 2 years earlier than anyone had expected, as electric and hybrid vehicles displaced an estimated 15 million tons of oil products in a single 12-month stretch. The International Energy Agency and the consultancy Rystad Energy both pulled their own peak demand forecasts forward to 2024. China's own state oil giant PetroChina projected a 2025 peak. Every one of these institutions was moving in the same direction, and every revision made the peak arrive sooner than the last one predicted. Then, in 2024, it stopped being a forecast entirely. China's annual oil demand fell for the first time in 20 years. Electric vehicle adoption alone displaced roughly 430,000 barrels of gasoline demand per day that year, a number researchers now project could quadruple by 2040 if the current pace of adoption continues. You can actually see this shift showing up in real time in a single holiday week. Every October, China's Golden Week holiday sends hundreds of millions of people on long road trips, and every year until recently, gasoline stations along every major highway braced for their single busiest stretch of the calendar. In October 2025, something different happened. Daily electricity use at public charging stations, the closest proxy analysts have for actual EV usage, jumped nearly 46% compared to the same holiday the year before, while gasoline consumption stayed essentially flat instead of spiking the way it always had. One driver interviewed by Reuters described taking a 2,000-kilometer road trip across the country in an electric vehicle for the first time, something he said would have felt impossible only a couple of years earlier, and finding charging stations within a few kilometers of almost anywhere he needed one. That kind of confidence didn't happen by accident either. China's public charging network grew to roughly 18 million ports by September 2025, up more than 54% from the year before, effectively erasing the range anxiety that used to be the single biggest objection to going electric on a long-haul trip. If this is the first time you're hearing how far this has already gone, that alone should tell you something about how quietly it happened. Stick around, because the mechanism behind it is stranger and more clever than a subsidy check, and the industry paying the real price for all of this is not the one you'd expect. Passenger cars were always going to be the easiest fight to win. A private car sits parked for the vast majority of its life, and its owner has a garage, a driveway, or a workplace lot to plug into overnight. Heavy trucks are a completely different problem, and for years, engineers on every continent assumed it was close to unsolvable. A long-haul truck cannot afford to sit still for hours waiting on a charger. Every hour parked is an hour of lost freight revenue. Battery packs big enough to move fully loaded cargo across 1,000 kilometers are heavy, expensive, and slow to refill, which is exactly why diesel held on to trucking longer than it held on to almost anything else on the road. For a while, some fleet operators bet on liquefied natural gas as the transition fuel instead, since LNG trucks were cheaper to run than diesel whenever gas prices sat low enough. Sales of LNG trucks in China surged through 2023 and into 2024 on exactly that logic. Then somebody solved the actual bottleneck, and it wasn't a bigger battery. It was a different battery altogether, one designed to be pulled out and swapped rather than plugged in and waited on. Battery swapping strips the slowest part of electric trucking out of the equation entirely. Instead of a truck sitting at a charger for an hour, a robotic bay pulls the depleted pack out from underneath the vehicle and slides a fully charged one into place in a matter of minutes, closer to the time it takes to fill a diesel tank than anyone expected possible. CATL, the same company that supplies batteries to a large share of the world's electric vehicles, began rolling out a standardized swappable module built specifically for heavy trucks, meaning packs built to one specification could work across dozens of different truck models rather than every manufacturer building its own incompatible system. That standardization mattered enormously because it meant a swap station built along one highway corridor could serve trucks from competing manufacturers, which is the only way a swap network becomes worth building in the first place. The results moved faster than almost any forecast had allowed for. Battery electric heavy trucks captured roughly 9% of new heavy-duty sales in the first half of 2024. By the first half of 2025, that number had climbed to 22%. By August 2025, it reached 28%. Then in December 2025 alone, monthly penetration hit close to 54% of every new heavy truck sold in the country, partly accelerated by manufacturers and buyers racing ahead of an expiring subsidy window, but still an extraordinary threshold for a category engineers had spent years insisting was the hardest one to electrify. Full year 2025 new energy heavy truck sales came in at 131,100 units, up 182% from the year before. Meanwhile, the LNG trucking boom that briefly looked like the future of Chinese freight began stalling out as the price advantage that had made LNG attractive shrank by roughly 2/3 compared to just a year earlier, squeezed from both directions by cheaper diesel and now genuinely competitive electric trucks. There is a piece of engineering trivia buried inside this story that almost nobody outside the freight and battery industry has ever heard, and it is worth understanding because it explains why the swap model scaled so quickly. Roughly a third of all battery electric heavy truck sales in China now involve swap-capable vehicles rather than standard plug-in charging, and that share has been climbing. Baibin Trucks, operating out of Inner Mongolia, showcased a dump truck built around a battery from EV Energy that recharges in about 22 minutes flat, competitive with a diesel refueling stop once you account for the driver's mandatory rest break. CATL, separately, launched what it describes as the longest heavy-duty battery swap corridor in the country, stretching 1,150 kilometers, letting a truck run that entire distance without a single conventional charging stop. Fleet operators running the swap model estimate savings of between $4,300 and $8,500 per truck per year in operating costs alone, because the model shifts the enormous upfront cost of the battery pack itself off the truck buyer's balance sheet and onto the swap station operator, who amortizes it across every truck that uses the network. The economics underneath all of this are the real story, more than the technology itself. Electric heavy trucks in China still cost anywhere from 62 to 255% more upfront than an equivalent diesel model, which sounds like it should be a deal breaker. But total cost of ownership tells a different story entirely. Once you account for dramatically lower fuel costs and higher energy efficiency, researchers at the Institute for Energy Economics and Financial Analysis calculated that electric heavy trucks run somewhere between 10 and 26% cheaper over their operating life than diesel equivalents. CATL has gone further, estimating that new energy heavy trucks can save close to 1.2 million yuan, something in the neighborhood of 177,000 US dollars, across a 10-year operating cycle compared to a diesel truck doing the same job. One manufacturer, Sany Heavy Industry, said a single export batch of its electric trucks could save customers roughly $22 million a year in fuel costs while cutting 80,000 tons of carbon dioxide, numbers that would have sounded like marketing fantasy a decade ago and now read as a routine sales pitch. There is one more piece of this that pushes it past a trucking story and into something closer to the actual breakthrough people mean when they talk about China's new energy push. Every battery discussed so far, in cars, in buses, in swap stations, has depended on lithium, a metal China does not fully control the global supply of and has watched swing wildly in price. In April 2025, CATL unveiled something it called the Naxtra battery, the world's first sodium-ion battery built for mass production rather than a laboratory demonstration. Sodium is not a rare or geopolitically contested material. It is one of the most abundant elements on the planet, extractable from ordinary salt. CATL's version reached an energy density of 175 watt-hours per kilogram, close enough to the lithium iron phosphate chemistry used in most Chinese electric vehicles that the trade-off stopped being a deal breaker. It supports a range of roughly 500 kilometers, holds up past 10,000 charge cycles, and retains more than 90% of its usable capacity at temperatures as low as -40 degrees Celsius, solving a cold weather charging problem that had genuinely limited electric vehicle adoption across China's northern provinces. In September 2025, it became the first sodium-ion battery on Earth to pass China's newest national safety standard for EV power batteries, a standard specifically written to eliminate battery fire risk at the source. By early 2026, Chang'an had begun selling the first mass-production passenger vehicle built around it, and CATL's own swap station network started integrating sodium-ion packs directly into the same battery swapping infrastructure originally built for trucks and taxis. None of that shift depends on trucking, on subsidies, or on any single country's politics. It depends on chemistry that is by design cheaper and more available than what came before it, which is precisely why bigger breakthroughs tend to be quiet ones. They don't need a press conference. They just need to be true. If you're finding the scale of this surprising, that's the entire reason it's worth a like and a subscribe right now, because the next part is where the plan runs into a genuine problem, and it's not the one most people assume. None of this happened by accident, and none of it happened without a plan sitting behind it. But there is a problem buried underneath the entire transition that almost nobody discusses when they talk about China's electric truck boom, and it is the part of this story that actually determines who wins and who gets left holding the bag. Here is the uncomfortable arithmetic nobody wants to put on a slide. Every barrel of gasoline China no longer burns domestically used to flow through a refinery that was built assuming that barrel would always be needed. Those refineries do not shut down the day demand falls. They were financed with decades-long capital plans, built by state-owned giants and private conglomerates that expected steadily rising fuel consumption for years into the future. Chinese officials have now acknowledged the sector is sitting on roughly 60 million tons of excess refining capacity, a gap created directly by the contraction in gasoline and diesel demand. The government's response has been to target the smallest, least efficient refiners first, threatening to shut down plants processing under 2 million tons a year, while capping total national refining capacity and pushing larger, more efficient operators to pivot toward petrochemicals instead of fuel. That pivot has its own consequences, and they are already spilling past China's own borders. As refiners shift output away from gasoline and toward chemical feedstocks like MTBE used in plastics and other petrochemical products, they've flooded that market too. MTBE prices out of China fell through much of 2025 as new capacity kept coming online even while existing plants operated at a loss, and traders in Europe are now bracing for a wave of Chinese MTBE imports arriving through the first half of 2026. Smaller independent refiners, the ones China's own trade press has nicknamed teapot refineries because of how modest their output is next to the state-owned giants, face the sharpest end of the squeeze. Regulators have signaled that plants processing under 2 million tons a year could be shut down outright, while private refiners have already seen their crude import quotas trimmed for 2026 compared to the year before, tightening the raw material available to exactly the operators least equipped to pivot into petrochemicals fast enough to survive the transition. China's own refined fuel exports actually fell nearly 3% over the first 11 months of 2025, not because the world wanted less Chinese fuel, but because Beijing capped how much refiners were allowed to export through a strict quota system, careful not to let a flood of surplus product wreck its own domestic refining margins any further than the shrinking fuel demand already had. The quota for 2026 sits at 19 million tons, split mostly between the two state giants, Sinopec and CNPC, a level regulators clearly consider high enough to relieve the excess without letting it become chaos. And here is the twist that makes this so much more complicated than a simple story about oil dying. Even as Chinese gasoline demand shrinks, Chinese refinery throughput actually hit a record high in 2025, processing more crude than ever before, close to 14.75 million barrels a day. That is not a contradiction. It is refiners running flat out to feed the petrochemical pivot and to capture export opportunities elsewhere in the world, even while the specific fuel that once justified building those refineries in the first place quietly shrinks underneath them. Crude oil imports are still climbing. It is gasoline, specifically, that peaked. That distinction matters enormously because it means China is not walking away from oil. It is walking away from burning oil in vehicles while using more of it than ever to make everything else a modern economy runs on, from plastics to synthetic fabrics to industrial chemicals. Zoom out far enough, and the shape of the strategy becomes impossible to miss. This was never really about cars. In 2024, China set a national target for new energy vehicles to reach 30% of its entire vehicle fleet by 2030, up from roughly 12% at the end of 2025, alongside a separate target for new energy commercial vehicles to hit 25% of that fleet in the same window. A dedicated plan covering 11 government ministries set an explicit goal for new energy trucks to reach 40% of new heavy truck sales by 2030, building toward a fleet of more than 1.6 million new energy heavy-duty trucks on Chinese roads, something close to a fifth of every heavy truck in the country. Behind that target sits real infrastructure spending, roughly 3,000 new charging and battery swap stations, 30,000 kilometers of what officials are calling zero-carbon freight corridors, and mandates requiring electrification rates above 80% on fixed short-haul routes in the most polluted industrial regions around Beijing. The strategic logic underneath all of it traces directly back to that old lesson about who controls the fuel. An economy that generates its own electricity, largely from domestic coal, hydro, solar, and nuclear, and increasingly uses that electricity to move its own trucks and cars, is simply less exposed to a choke point on the other side of the world than one that depends on tankers threading through it. In 2025, close to 15 million barrels of crude oil a day passed through the Strait of Hormuz, with China and India together receiving 44% of that flow. Analysts now estimate that China's electric vehicle-driven displacement of gasoline demand already equals close to a tenth of everything that normally moves through that single strait. That does not make China immune to a closure of the strait tomorrow. It makes China measurably less exposed to one than it was 5 years ago. And the International Energy Agency now projects electric vehicles could remove more than 4 million barrels a day of Chinese oil demand by 2035, offsetting more than a quarter of everything that passed through Hormuz in 2025 alone. The rest of the world is starting to notice, and not just as spectators. Manufacturers like BYD are already exporting roughly a fifth of their electric trucks abroad, with Southeast Asian mining operations in places like Indonesia emerging as an early export market for equipment originally engineered to solve a domestic Chinese problem. The International Energy Agency's global EV outlook now projects electric vehicles could displace as much as 8 million barrels a day of global oil demand by 2030, as the pattern China spent a decade proving out in its own market: buses first, then cars, then the hardest category of all in heavy trucking starts repeating in economies that were watching and waiting to see if it would actually work before committing capital of their own. Every one of those countries gets to skip the decade of expensive trial and error China absorbed first. They get the standardized swap batteries, the cold weather chemistry, and the total cost of ownership data already proven out at scale, which is its own kind of leverage. The country that runs the experiment first usually ends up selling the equipment to everyone who watched it work. None of this means the fuel industry disappears next year, and it's worth being honest about the counter-argument because the story is genuinely more balanced than a simple headline suggests. Refining giants like Sinopec are still projecting that stronger petrochemical demand and export opportunities could improve China's overall oil demand outlook heading into 2026, even with gasoline in structural decline. Global refining capacity is actually tightening in 2026, not loosening, as aging plants in the Middle East run below capacity and China's own export quotas limit how much relief Chinese refiners can offer the rest of the world, a dynamic that's already pushed fuel prices in some regions back toward levels last seen after the 2022 invasion of Ukraine disrupted global energy markets. December's record-breaking truck sales numbers were also partly a rush to beat an expiring subsidy, which raises a fair question about whether 2026 growth continues at the same pace once that incentive disappears. Electrification solved the easy fleets first: buses with predictable routes, then passenger cars with driveways to plug into, then, improbably, long-haul trucks with a battery swap model built specifically to answer the one objection that used to make electrification look impossible. Whichever of those forecasts turns out closer to correct, the fact that this is even a live debate about the world's largest oil consumer would have sounded absurd a decade ago. So here is the actual question worth sitting with. A country spent 2 decades systematically re-engineering its way out of dependence on a fuel it could not control the price of, starting with buses nobody was watching, moving through a sodium battery chemistry nobody had made cheap enough to matter before, and ending with a swap network capable of moving an 18-wheeler across 1,250 kilometers without a single stop at a pump. Is that the most significant industrial pivot of this decade, quietly reshaping how the rest of the world eventually breaks its own dependence on oil? Or is it a strategy still one subsidy cliff and one global refining shortage away from proving it was ahead of its time in the wrong direction? Leave your answer in the comments, because this is exactly the kind of shift that looks obvious in hindsight and completely invisible while it's actually happening, right up until the moment somebody adds up the numbers and realizes the fuel industry already changed underneath everyone's feet.